a little bit muddled. So they just want to kind of clarify things and not really take sides. So you can see there, you get your credit for your CE hour. And so very often I'm doing this in front of a group of design professionals, architects, engineers.
Tell you what, I did that homeschooling for a while, Michael. It is not fun. You're going to be sending the governor nasty letters real quick. I hope you and your wife have patience levels through the roof if your children are anything like mine.
It's already happened. So, this kind of describes, you're going to get some, this is probably a little bit better here. Learning objectives. Okay, I'm going to tell you all you're going to ever want to know about panels in this next hour. So, energy efficiency is probably the most important reason why people think about building with SIP panels. People that want to build a house, they have a budget, they want it built better than just a code. And they have the money to do it, so they search out these higher end building products, and one of ours fits into that category. So what are SIPs? So most of the SIPs manufactured in the United States use an EPS core, so that stands for expanded polystyrene. You do have, there is one company that is a member of SEPA that makes a polyurethane panel. There's some limitations to polyurethane, although it does have a higher R value per inch than EPS. So it is a product that's available out there, but it's really kind of fading out in the industry, to be honest. So there's been a few other companies that have closed up or dropped out of the Structural Insulated Panel Association altogether. The 7/16 OSB is an industry standard. Believe it or not, we can buy that 7/16 OSB in 8-foot by 24-foot long sheets, and we can make some really big panels with that long skin, and we can make it with different facings as well. We're working on a project right now where we're using a BC plywood for one of the interior side for a ceiling in a grocery store in South Carolina. They just want that look. We can certainly do that, but that limits the size of the panel to the size of the sheet material, in which is, in that case, it's 4x8. So SIPs have been around for a long time, actually, about 90 years. That was the idea, was to try to get a structure built with not as much lumber as what is typically done. So they experimented with some different types of skins and different types of cores. Alden Dow in 1969 was the first one to make SIP panels with an EPS core, so that we can buy all that chemical from Dow, and that is the predominant core that's made in the industry. We make some panels for specialty applications with different cores, expanded polystyrene and polyisosanurate as well, but those are very, very narrow applications. So this is the anatomy of a SIP panel. Basically what it is it is a foam core with two skins, glue laminated with structural adhesive. You can see there that at the bottom it is pointing to a wire chase. People are always asking how they get the wires run in the panels, and it is done through a wire chase. I'll talk to you a little bit more about that. There's another slide later on. There's also some non-load bearing SIPs. SIPs that are installed on timber frame or pole barn structures is a really popular application. If you walk into any log and timber frame home show, everybody that is displaying their wares, it will have a sample of a SIP panel on their table. I mean, it just goes together really well. And SIP panels are really fast an efficient way to get that expensive timber frame closed in and in the dry. And these other applications for that they show here, sunrooms and coolers, are also ways that SIPs are used. The big buzz in the industry is these magnesium oxide skins. We don't have testing for that type of panel, but my engineer tells me that he can extrapolate the values from our current load tables, and so we can actually design and quantify a structure built with MgO skins, which is short for magnesium oxide. So people are attracted to this type of panel because the skins are cementitious, so they're not going to burn, although the EPS will melt when it reaches a temperature of 165 degrees. But also it's impervious to water damage, and that is the real draw. There is currently one dedicated MgO manufacturer that is a member of the Structural Insulated Panel Association down in Florida. And so, but once again, as it is with plywood skins, the MgO is limited to 4x8. I believe we can get 4x9 sheets as well in that panel. So a lot of companies, ours does as well. We fabricate with CNC, and we install any lumber that needs to be installed inside the panel. We go ahead and install it at the plant, and then anything that is loose, like top plates and bottom plates on walls, we ship it loose. Especially commercial industrial project managers really like that service because they don't have to worry about any of the ancillary things that need to be incorporated into our system. Many of them aren't familiar with the system. Maybe about 1 to 2% of all new construction is built with SIPs. So it's actually a pretty rare bird to come across somebody that has experience with the panels, which is the reason why us and many other SIP companies offer on-site consultation free of charge. When the panels arrive at the job site, we send a representative to basically show the crew how to do it. Whenever I go, I'm pointing and instructing a lot in the morning, answering a lot of questions, and after lunch, I'm just trying to stay out of everybody's way. I mean, they get it. It's really pretty easy once you're just shown a few basic things. So these are connection details showing how the panels go together. These are and a lot of these details are actually uncommon. This is a nice detail if you want to further reduce the thermal bridging in the studs. But basically, if you're designing a house with a 9-foot ceiling, you're going to get 8-foot by 9-foot tall panels coming onto your job site, and you're going to have these connections every 8 feet connecting the panels together in plane. And the red that you see there indicates sealant. Every manufacturer has their own method of sealing. We just ask for one caulk line. The sealant does have an adhesive quality, but the panels don't need to be glued together. They are nailed together every 6 inches on center through the exterior and the interior skins. This is another very uncommon thermal spline. They call it a block spline. So it's basically just a skinnier SIP that we rip down to 3 inches in width, and it receives the connecting nails. And like I said, it reduces the thermal bridging. And I'll talk a little bit more about thermal bridging in another slide.
Steve was asking about, the R values for a SIP panel can be from very little to a whole bunch, right? Is there a standard R value that SIPs are, 6 inch, 8 inch, 10 inch? What a little bit, are you going to get to R values? He just chatted in and there was a little break I thought I'd ask.
Mm-hmm. Yeah, there's 5 common thicknesses of SIP panels, and the thicknesses are dictated by the measurement of the dimensional lumber that's available out there, 2x4s, 2x6s, et cetera. So the SIP panels are 4.5 inches overall thickness, 6.5, 8.25, 10.25, and 12.25. And there's even some thicker panels that we can make. So the R values run from R17 on the 4.5 inch thick to an R50 on the 12.25 inch thick. And those are prescriptive numbers. The performance numbers are much higher. And that's on a standard EPS panel. There is a product that's relatively new. It's BASF markets it as Neopore, and it is graphite injected EPS. The EPS is a slightly higher density. It's a 1.15 pound per square foot or per cubic foot instead of 0.95. So it has a higher R value. So it changes that R17 in the 4.5 inch, which is like your most common wall thickness. It goes from R17 to R20. So this connection here is probably the most common. People like using lumber spline just because it's what they're accustomed to working with. So some connections might require double lumber. Sometimes you have triple, 3 times, 4 times, especially if you're building a support column that's managing a point load coming down in some area from the roof or a little bit further down on the wall. Nothing fancy here. The panels in the corners, whether it be an outside corner or an inside corner, they just kind of lap together there, and there's long SIP screws that screw through the exterior skin, pass through the interior skin into a 2x4 in the adjacent wall panel. Every 12 inches on center is pretty standard. Anytime you order some SIP panels, your SIP supplier should supply those screws. They can get quite long. They can get up to 18 inches long, especially if you're using a really tall SIP panel in a valley or a ridge. What we like to see is a minimum 1.5 inch bite into that lumber. An engineer, depending on where the structure is being built, will call for a more frequent screw pattern. I'm working on a project in Florida right now where they want us to put the screw every 3 inches on center. They're designing for high wind uplift resistance on the roof. And then you can see all the caulk there. Every SIP company will do a set of panel layout drawings, and basically that is a instruction booklet on how to put the panels together, and they should have all these connection details, all the pertinent details related to that particular project in those drawings. The SIPs are pretty strong, and they're really good at resisting axial loads. So a lot of times what this illustration shows is these are what we call in the industry a punch out. So we can just punch a hole in the panel for doors and window openings, and the SIP panel that's above those openings, depending on how wide the opening is and how much you have there between the header and the bearing point for the roof, it'll pretty much be strong enough to handle the uniform load that's coming down on that panel. So the rule of thumb is as long as the opening's not wider than 5 feet and you've got at least 12 inches of panel above it, it'll be able to handle the load. But my job and the job of our design department, and especially our engineer, if we're using one, we will look at each case in point and make sure that the SIP panel has the capacity to do that. And if it doesn't, we'll design some header material in there, maybe 2x12s or LVL. Okay, this is kind of like the best practice, but like I said, once again, it's a very, very uncommon, but it's the best way to accomplish getting insulation in the rim area. Typically, they run that floor truss all the way out to the exterior skin, and the SIP panel just sits right up on top of that floor. You'll notice at the very bottom, there's a treated 2x that serves two purposes. Not only is it the mud sill that they are attaching your floor trusses to, but it actually creates a capillary break between the SIP panel and that concrete ICF wall. You don't want the OSB skins touching the concrete because it has an opportunity to wick moisture up and eventually degrade and rot the skins of the panel. So that's why we always call for that capillary break if you're building directly on a stem wall, foundation, any concrete slab, things like that. This detail is utilized for multiple stories. So if you're building a 2-story home or structure, what you'll do is if you have 8-foot ceilings designed in there, we'll provide you with a 9-foot tall panel. And then you use that top flange floor joist that you can get from Simpson. We'll make those, and the fastener goes through the top flange and it just kind of hangs over. And you run your floor sheathing all the way out to the exterior, attach that down, and then you just repeat by putting a 2x4 down and then just setting your next wall panel on top of that. This is a pretty common connection detail for roof panel to a wall. The wall can either be angled as you see it, or it can be straight across, and then just a piece of scrap that's ripped to the angle of the roof pitch can be inserted. What you want is a minimum 1.5 inch bearing for that roof panel at each bearing point. So at the ridge, you know, basically when you're building, designing with the roof panels, they have enough strength to where you don't really need trusses. Okay. In our area here, we have a 15-pound snow load requirement. And so if you add a 10-pound dead load, you know, you've got a 25-pound total load, and a 8 1/4 inch thick roof panel, which is just the most common one used, can span 18 feet between bearing points with no other structure underneath it for support. So they can span pretty long, and just a ridge support. It could be any kind of engineered lumber. Usually we use LVL or glulam or something else. If the span isn't that great, it can be utilized.
And that would be a one piece, an 18-foot manufactured SIP, right? It wouldn't be, there wouldn't be a joint in that 18-foot span.
That's correct. Yeah.
Okay,
So
just making sure.
so we can, you know, they get the OSB in 24-foot long sheets. So if the span winds up being greater than 24 feet, then what we do is we design a mid-span support there to handle the break in the panel, because we would need more than one panel to make that span. But for most residential applications, we don't usually need mid-span support. Now, if you're designing with polyurethane panels, you would have to have that, because the thickest panel they make is only 6.5. So they can't make an 8 1/4, 10 1/4, and 12 1/4 with polyurethane. So this is a pretty common application. I've got a builder in East Tennessee that does this a lot. What they do is they get a truss with an energy heel like that, and they blow 24 inches of cellulose insulation up there and just use SIPs on the walls, and they call it an energy efficient home, and which is what it is. It's not the best that you can get, but it's pretty good. And for their particular market, I have another builder in Charleston, South Carolina, that does this almost exclusively. Anytime you're using SIPs for the entire envelope of the house, including the walls on the roof. If it's a one-story home, 2/3 of your SIP cost is going to be in your roof. There's just simply more square footage up there. The thicker the panels are, the stronger they are, but the more expensive they are. And you need that R value up there, so they're going to be thicker. So they just have a business model where they can kind of hit that, get you something that's pretty good, and just use SIP on the walls and use this roof design like they're showing. So this is a picture of those long screws. You can see the screw tip all the way on the right has kind of this drill point. So if you're in some industrial commercial applications, they're using metal trusses, we can provide a screw that will self-tap through metal trusses as long as the steel is no thicker than 3/16 of an inch. If it is thicker than that, typically they're lagging a 2x4 wood onto that so that they can use the wood screws for attachment. So foam is sealant is very important with the panels. The nice thing about SIPs is if you're designing with using 8x24 sheets, you have a lot less areas where you can leak air. They're mentioning plumbing stacks and chimneys here. So we usually recommend cutting the hole a little bit larger, about 3/8 of an inch larger all the way around, so that once you get that plumbing stack run through the roof, then you can go back and backfill with expanding foam. Great stuff, works just fine. The froth packs that they show here, I haven't sold froth packs in years. The builders, the guys out there in the field just really don't know how to use it. They're about $500 a piece, and they're always complaining that they run out. They can't get all the foam out of it. So I just sell the cans with that foam gun dispenser, and that pretty much makes everybody happy. So the wire chases are basically tunnels that are inside the foam, and they're about the ones that we make are about 1.25 inches diameter, and we run them horizontally in every wall panel at 16 inches and 48 inches from the floor. That's not something that's set in stone. I've moved them before. I've done additional wire chases. Vertically, you typically have a wire chase in the panel at every panel joint. That's the way our company does it. And once again, that's not something that's set in stone. We can do custom wire chases. We do that a lot for vaulted ceilings. We have people that want ceiling fans and can lighting up in those panels. And so we just coordinate where those wire chases are going to need to be. And then when we produce them, we put them in and ship them, and the electrician goes ahead and runs the wires.
Is the chase just a cavity in the foam?
Yeah, I would say a tunnel, so, and when the guys do it, that's when it's made, that's basically what they do. They just,
What it is. Do you hear from electricians pulling wire? No issue?
they're not happy about it for the most part.
Okay.
Anybody that's working with something that they're not accustomed to working with, they're not happy about it. But I tell you, in the 14 years that I've been doing this, I can probably count on one hand the amount of electricians that I've actually spoken to over the phone about how to run wires.
Okay. It's standard NM, just yellow jacketed Romex. Okay. To use?
Yeah. That's pretty much what they do. Unless you're building in Cook County, Illinois, they require thin wall conduit. So then there's different things that we do for there. If they're using masonry exterior, they can run the conduit outside. Some people, I have a builder in North Carolina that after he gets the SIP walls up, he stick frames the wall on the inside, and he runs the electric in that. The Structural Insulated Panel Association has actually done a time and motion study, and it actually takes less time to run the electric in the SIP panels than it does conventionally framed home. You don't have to drill holes through all the studs. You don't have to staple or clamp the wire in a SIP panel like you would in a stud wall.
How do
So
you get away? You would think the NEC within 12 inches of the outlet requires the Romex to be secured. You don't have to secure it?
not with a SIP panel. I mean, there's simply no way to do it.
Hmm. I wonder if an inspector's ever, I bet you y'all have had some inspector issues with an electrical inspector on this.
Never one time.
Huh. Okay.
Yeah. Yeah. So um, I'll address a little bit further on what my interaction with code officials has been, but never been on never on electricity, never an electrical inspector have I spoken with. So there's two dynamics that make the SIP system perform better than conventionally framed systems. One is reduced air infiltration. The other one is reduced thermal bridging. So since 2009, it's been written into the IECC. There's a performance path and a prescriptive path to meeting the minimum R value requirements. So, and that's because they recognize that the SIP system as a whole just simply performs better. Anytime the code talks about R value, they're talking about fiberglass, okay? So as you see there all the way on the left, the 6-inch SIP wall has a prescriptive R25, but its performance value is actually R38. So what that means is that if you wanted to stick frame a wall that would perform just as well as a 6-inch SIP wall, you'd have to use R38 fiberglass insulation.
Yeah, when you're doing your performance report, just because I've got a lot of inspectors on here. So like a res check or a IC3 or rim rate or ecotrope, any of those performance calculators, you wouldn't enter for the performs as R value, but you would make sure and let the software know that you are using a SIP panel rather than wood framing, and it should do those calculations for you.
I think that might be the case now. In the past, Resnec and ComCheck have not been kind to SIP panels. It used to be that I used to have to enter the performance values in order to get it to work, but I've been told that that those programs have been updated to more accurately recognize the performance of SIPs. So I just when people ask me, I tell them, I said, if you want to use the performance path, you just need to talk to your code official and see what they're going to require you to do. You know, they might want a blower door test. They might want a HERS rater to come in and do a rating.
Yeah, in Texas, we're on, for the vast majority of jurisdictions, we're on the 15, so that does require the blower door and the duct blaster. But yeah, code officials, if you have a SIPS project on your desk, and for some reason, there's no reason in the world why that home will not meet the energy code. So if it's not meeting the energy code, they simply haven't filled out the paperwork correctly. So just let me know, and I can help walk them through to make that comply, because a SIP home is going to meet the intent of the code, which is to save energy all day long over traditional frames.
Yeah.
So happy to help.
And one of those reasons is explained in these photographs that you're seeing here. You know, thermal bridging is a really big deal. You know, wood only has an R value of 1 per inch. So where you can see all that wood framing on the left, all those dark areas, you know, if it's a 2x4 studded wall, it's only performing at R4 in those areas. And it doesn't seem significant, but somebody actually measured all that surface area on an average wall, and it comes out to be 25% of the surface area of your average wall when you take into account your headers and your cripple studs and jack studs and all that put together. When you build with SIP panels, you cut that down from 25% to 3%. And there are some projects that I've been involved with where we've actually had some special details where we have eliminated the thermal bridging altogether on some passive home designs and near net zero designs. it's really gotten pretty low. You know, if you're designing a home with an 8-foot tall ceiling, you can have an 8-foot tall SIP panel 24 feet wide, and it only has a stud at each end and no other stud besides for the plates in that wall. So this just kind of illustrates, you know, you have a more consistent R value. That bottom left hand shows you with the wood frame fiberglass, you know, not as much. So the other dynamic is air tightness. Okay, so they're showing the blower door test of a SIP home, and it has basically half a full air exchange per hour. A lot of stick frame homes, that value could be 10 times greater. So that means that all that air that's being conditioned inside the home is staying in there longer, meaning that you're not running your air conditioner or your furnace nearly as much. And which goes to, this is what I tell all my builders, is to use an HVAC professional that is going to do a manual J calculation so that they don't oversize the units. And it's one of the ways in which they can save money initially on the build, is because they're spending less on the units because they're smaller.
And I would imagine you want to make sure your whole house mechanical ventilation is something other than just an exhaust fan running in the laundry room.
Some people install a fresh air exchanger. It's one of the things that I'm not an HVAC guy, but it's one of those things that I've heard that's a lot easier to do in the new construction phase than it is to retrofit afterwards.
Yeah, for sure. Yeah,
Mm-hmm.
you would want to use, I would think you would want to, at the bare minimum, use a supply only strategy, like a Q-Fresh or some sort of supply only strategy.
Yeah.
You know, ERV, of course, would be the Cadillac down here in Texas, but I would think a supply, some sort of continuous outdoor air being brought in.
Yes.
Smart, preferably.
I have a builder in Pennsylvania that he has a model home built up there, and he says whenever they run the fireplace, they have to crack a window because there's just not it just provides more oxygen, and the fire burns higher than if they don't crack a window. So yeah, you're getting into, you know, a tight envelope it's going to have certain dynamics to it. The only time that I've really had anybody have a concern about the fresh air exchanger is their fear of mold and mildew inside. So people that are building in areas where the humidity is extremely high, I recommend that they get that done. So caulking is very important to SIP construction. We provide an EPS-friendly caulk sealant for all of the packages that we send out. And we do about 125, 130 unique individual projects per year. And that is just a primary purpose of the caulk, is that all the joints get sealed up. There's also something that you won't see in this PowerPoint here is a SIP tape. And basically all the projects that I sell that are in the extreme northern climates, I sell them some seam tape to go over the roof panel joints. Building science tells us and demonstrates that anytime you have indoor air that wants to get out, it goes through the roof. So if you have a leak in one of the SIP joints, then that causes continuous airflow. And so any moisture vapor that is in the air will attach itself to the OSB and cause rotting of the panels at the joints. So we want to make sure, just in case the guys building it, it's 5 o'clock on a Friday and they want to get out of there. Maybe they're not as conscientious with the caulk. So we have that extra added protection of the SIP tape for the roof panels. So there are, Energy Star is one of them. There's a lot of different energy programs out there. Some states even have their own, but the Energy Star has seen enough SIP homes where they waive the requirement for the blower door test if you want to qualify for it. I get LEED is another one, and I'll get to LEED. A lot of people just build to the criteria, but don't bother with the certification unless it's a municipal project. I think there's a political component to being able to say, yeah, we have certified Energy Star or certified gold or silver LEED, for this school, library, etc. People that are building residential, they're just not going to do the paperwork and pay the money for it, but they'll just have peace of mind that they have a quality home. So that SIP home that had that blower door test of 0.53 lowers that HERS rating down to a 65. So almost halfway to a zero energy home, just building with SIP panels. There's other things that you can do. They'll integrate solar panels or radiant floor heat, different things to make the structure more energy efficient. Definitely creating that fully enclosed envelope around the conditioned space is a good way to start, and that's where SIPS comes in. So this just kind of gives you an idea of the SIP R values and what they are. I think that there's kind of a debate in the SIP industry right now because EPS has different values tested at different temperatures. So the lower the temperature is tested at, the EPS actually performs better. So it's just depending on what temperature, whether you're looking at 25 degrees, 40 degrees, or 75 degrees, you're going to get slightly different R values on that. And I just want to point out, if you look at the polyurethane, they don't have any R values past 6.5 because it's just physically impossible to make thicker polyurethane panels. A manufacturing process doesn't allow for that. So LEED is another program where you can earn points building with SIP panels. This chart just kind of gives you a little bit here. The FSC certified OSB, there are a number of companies in SEPA that have chain of custody to FSC certified OSB. That's the Forest Stewardship Council, and you get a point for that. We used to be able to get that OSB in 8x24 sheets, but they ceased making it. The demand just wasn't there, but you can still get it in 4x8 sheets. So SIPS, Title 24 is, kind of like every state has its own criteria for meeting your minimum R value. In California, unlike other states, has its own requirements. So SIPS can help to meet those. So the third bullet point there is what most consumers of SIP panels are looking at, because it's more expensive initially to build, even though you're going to be spending less money on things like labor and your HVAC, and if you get a ready to assemble package, you're not going to have any job site waste to get rid of. So generally we say 5 to 7 years is when the energy that you save will pay for the extra money that you spent on the SIP panels, as opposed to stick framing and fiberglass insulation. So once again, it's something that I always tell my customers to talk to their building department before they go ahead and purchase the SIP panels. Anytime, I'm going to say maybe half, 50% of all the projects that we do are SIP walls only or SIP roof only, especially in commercial. We're seeing with the R value requirements going up, SIP panels are actually becoming the cheaper method to construct certain commercial type buildings and meet the minimum R value. Those people that for those projects, I always use the prescriptive number simply because they're not doing the whole envelope in SIPs. But if it is a structure that where the whole envelope is SIP panels, then I always recommend that they consult with their building department. And they pretty much, I've never had anybody reject a whole building envelope with SIP panels using the performance numbers. So I think it's pretty solid. What it is that they have to do to satisfy their building department, other than getting a letter. I've written a lot of letters stating what the performance and prescriptive numbers are to a number of building departments. Simply because we're a manufacturer, they will accept that. And so when I discussed earlier what my interactions with code officials has been, it's usually been on our code report. Okay, so any manufacturer that's a member of the Structural Insulated Panel Association is required to have an engineering report. So what we do further than that is we send samples to our engineering company every 90 days, and they put the panels through the testing to make sure that our manufacturing process is consistent and that our panels are performing up to our code, just to make sure that the OSB that we're getting and the EPS that we're getting and the glue that we're getting is all consistent, and we don't have any defective panels that are leaving our plant. Our company, and there are some other companies in the Structural Insulated Panel Association, do offer a lifetime warranty against delamination for our panels. There are a number of companies, I think a majority of them, that only offer a 20-year warranty against delamination. And there are even a few that only offer a 10-year warranty on delamination. As a sales rep, I'm thrilled to work with a company that offers a lifetime warranty, because I can compete in areas of the country where normally I wouldn't be competitive. We manufacture in Louisville, Kentucky. I sell a lot of panels out west in places like Colorado, Washington State, Utah, Wyoming, because those customers value the fact that we offer a lifetime warranty on it. And there are some companies out that are out west there that only offer a 20-year warranty, and that's just not good enough for them. And I don't blame them. So a lot of times I'll get a customer saying, you know what, my building department, the people there have never heard of SIP panels. I email them this 19-page PDF file and I say, give this to them. And that usually gives them peace of mind knowing that they are building with a tested, engineered building component. And as a result of that testing, you know, this is a load table. It's not something that represents our company's load tables, but some other companies work with these type of load tables. And this is what we use and what our engineers use to do the engineering calculations on a particular design. Usually all non-residential structures receive a PE stamp on the panel layout drawings, showing that the design has been reviewed and that it is going to be structurally sound. North Carolina is the only state of the union that you can't build a doghouse without having a PE stamp on the drawing. So all residential projects that we do in North Carolina receive a PE stamp. And generally all the counties that have major metropolitan areas like Fulton County and Georgia, Cook County, Illinois, Jefferson County here in Louisville, they're going to require a PE stamp on a residence as well. So this is some of the applications. SIPS and ICF go really well together. Some people, they like the ICF, they like concrete construction. And I believe that you can do ICF for a roof, but I think it's extremely expensive. So SIPs are a good substitute for that. It's listing here, SIPs over timber frame. Like I said, really common application. Probably about 10 to 15% of all the SIP sales that we do are being installed over timber frame structures. There is one non-structural, a very narrow application for a SIP panel called a nail base. So it only has OSB skin on one side of the panel, and it's intended to go over an already existing structure. So you have a house that was built in the 30s and they didn't insulate the roof. You want insulation up there, and you need to replace your roof. So what you do is your roofer goes up there, scrapes all the shingles off the roof, and then they install this nail base panel down on top of the structural deck with the foam side down and the OSB side up. So once they get that all fastened to the roof, cut the size, then they have something to attach their new roof shingles to, or metal roof, or whatever roofing you're using. And this can also be done on the walls, but that's like I said, that's a very, very narrow application, but it can be done and it is available. We've done a number of SIP structures with Habitat for Humanity and different organizations that are not Habitat, but do the same thing in different locations of the country. One of the advantages is that once it's built, it makes it much more affordable for the people to stay living in there because their utility bills are almost cut in half. So we've done a number of projects like this where the SIPs are built on top of pilings. It's a good application for a SIP floor, especially in a place like Louisiana, because they want a minimum R17 in the floor when you're building up in the air like that. So what we see is people putting in their piers and their beams, and then they put in their I-joists like it was going to be a conventional floor, but instead of putting a subfloor down, they put the 4-inch SIP panel down on there first. It gives them the insulation and the subfloor all in one step. These modern looking contemporary monoslope roofs are really SIP friendly because the panels are so long, especially for the structure you see on the left. You could probably just use exterior load bearing walls and not have any beams or trusses or anything underneath that panel for support. Here's another look at a couple timber frame homes. If you look at the home on the top right, I get a lot of people asking me, they're considering building with SIP panels and they want to go see a SIP home that's already been built. And I tell them, I says, you can go and look at it, but it's not going to look any different than any other home because once it's built, the exterior is finished, interior is finished. You can't see the panels. So it's just done. All you can do is talk to the people about how they're enjoying their low energy bills. It is possible to build a curved roof panel out of SIPs, but most of the time what we do when that happens, and I can say that I've done this twice in the 14 years I've worked for FischerSIPS. It's just a lot easier to make a bunch of kind of segmented wood, wedged panels and piece them together, and then you get the curve when it gets trimmed out, and that's just the easiest way to do it. Some pretty basic designs right there. Anything can really be done with SIP panels. Roof design, like I explained earlier, you might have to have some mid-span support like they're showing there. They got a beam at the ridge, and then you see about 6 feet down from the ridge, you can see on each side they have an additional support beam. Some designs are just not very SIP friendly, and so they just use conventional trusses and install the SIPs on top of those. But I'd say probably not 98% of the SIPs roofs can be designed using this beam structure to support it, and then the trusses are dispensed with. Some people need to design with a really thick SIP panel because they need the R value or they need the strength for the span, but they don't like the look in the eave. So what we can do is, as it's showing in the picture on the left, is we can put pockets in the EPS, and they can be made to receive a rafter tail. Those look like, if they're a foot long, then the pocket's going to be 2 feet deep. So you'd have a 3-foot rafter tail sticking out, and then you just ladder frame, stick frame on the outside. If that's the look that you want, it can certainly be achieved with SIP panels. So that just kind of shows the caulk line, and that's really close to what our detail would ask, is just one bead, continuous bead. You see it's unbroken all the way down to the floor, and that's going to create the seal. And you can see there's really just 2 guys working on this. When you get to the roof panel, that's kind of when you're getting into the range where you're going to need some type of equipment. The panels weigh about 4 pounds a square foot, but when you're getting into 8x24 panels, you're talking about 600-700 pounds a piece. So you need equipment to get it up there on the roof safely and installed. So there's a lot of pre-planning and pre-design work that's done with SIP construction, more so than you do with stick framing. One of the decisions that needs to be made a little bit earlier than in stick framing, because you can get doors and windows in about 2 to 3 weeks, but it takes us about 6 to 8 weeks to get a project from the planning phase to delivery. So our CAD operators need to have that rough opening schedule a little bit sooner, so that we can get those holes cut to the correct size. And when talking about a complex design, I always tell people, design the house that you want to live in and that you want to build, and let us worry about designing, making the SIPs work for it. So here's your course summary. Usually what I'll do is take time for questions. If this was an in-person presentation, I would make myself available to speak to people on an individual basis for questions. But if you have any further questions, even if it's not about this presentation, but about SIPs in general, if at some point, a week, 2 weeks, a year down the road, you come across something and you would like to ask a question, feel free to reach out to me. I'd be more than happy to talk to you about it. That's the end of the presentation.
Thank you very much, Michael. I did have a few questions come in that haven't been answered yet. For like a SIP on an exterior wall, if you've got a bunch of cabinets and stuff, would you install blocking in there, or would just that 7/16 OSB be okay? Or
We can install blocking in the panels, but it's not necessary for cabinets. I have a fastener withdrawal chart from Weyerhaeuser that can prove that, but anecdotally, we actually did a test. We set up a SIP panel wall in our plant, and we screwed cabinets to it, and then we filled the cabinets with bricks. And then we left, and the next morning we came, and the cabinets and the bricks were on the floor, but the backs of the cabinets that were screwed to the SIP panels were still attached.
yeah,
So the 7/16 skin was actually stronger than the cabinets themselves.
I've had 2 or 3 questions come in about wind upload and building in hurricane areas. I'm assuming that's just fastener pattern and fastener type, and SIPs isn't precluded from any windstorm regions whatsoever, right?
Not precluded. Not only that, it's very rare for us to have an engineer call out any kind of hurricane strapping or additional tie downs. In areas where there's seismic comes into play, sometimes we do have to design with tie downs, but generally for wind uplift, it's just more screws that they want. That's basically all it is. Our standard is 12 inches on center. If we're building in Ohio, if we're building in Miami-Dade, it's going to be 3 inches or 6 inches on center, and that's basically all that they want.
Yeah, and I did have a question so Texas Department of Insurance has got a little, racket, for lack of a better word, going. That they'll send out a TDI for short, a Texas Department of Insurance inspector, and the TDI inspector, the only report they're allowed to accept is that your product has been tested at a TDI facility and passed the test. And I had this come up down on the coast, and this lady's like, man, I spent $8,000 for this door. They told me it was approved, good to go. Well, it had the Miami-Dade certificate, which Miami-Dade is the Cadillac of hurricane design and criteria. And come to find out that the TDI inspector comes out there and says, no, I can't accept this. It's got to be tested through TDI. So she spends another like $7,000 having this door tested at TDI, when she could have spent an extra $100 and had a TDI approved engineer come out and say, look at the Miami-Dade report and say, yep, this will be fine. And just boom. But the TDI inspector didn't tell her that. All he told her was, I can only accept it if it's been TDI approved. So I'm trying to spread that, let people know that are designing this left and right.
That's interesting. We've got a big green dealer down in the Dallas-Fort Worth area that uses our panels a lot, aside from other people. And I'd like to talk to him about that and see what his experience has been with that.
A couple more. Are floor SIPs designed with thicker subfloor panels?
Well, that's a good question. We can make the panels with any thickness skin that's available in the OSB. So we can make them with 5/8 or even 3/4 inch skins. Mm-hmm. But if they're building with 7/16, it's pretty strong, but we would like to see another layer over the top of that for a floor, just because if you're setting down a big heavy piece of furniture or something like that and creating a point load, just might crack that 7/16 OSB. So yes, we recommend when they're using it as a floor, if they're not using a thicker skin, to go ahead and go down with another layer of 7/16, give you a good solid subfloor.
Okay. Says, are exterior joints taped, and how do you attach wall covering, stucco, or face brick?
You're going to attach a siding just like you would any other conventionally framed.
Any other. So it's just like sheathing. You put a weather resistant barrier on it and attach it just the same way, right? No different.
Correct. There are certain siding where we recommend that you create a drainage plane. So that means furring strips on top of the house wrap, minimum 1/4 inches thick, and then attach your siding onto it there. It creates an air gap where water, if it gets back there, will evaporate before it causes any damage to the OSB. Of course, you got your house wrap on there, but if it'll eventually break that down if it stays moist. There are certain hardy sidings and wood sidings that have a tendency to leak rainwater. And so if we know that anybody's using that, that's what we recommend that they do. The SIP panel is different than sheathing in that the loads are transferred through the skins. So we're really fanatical about keeping that OSB intact. And in a conventional structure, the sheathing can easily be repaired, and it can be easily repaired if it's a SIP panel, but that is the structure. And so we really want to make sure that OSB stays dry and intact.
Yeah. So if you're an inspector and I imagine. Last question. We're a couple of minutes over. Thanks so much. Fantastic presentation. This is our first SIPS presentation in 5 years with Spear, and I learned a lot, and hopefully a lot of other folks did too, and can kind of direct their builders to these options rather than just the traditional framing. You mentioned a green builder in the DFW area. Donnie was just asking if it's Don Ferrier.
Yes, that's who it is.
That's funny. Yep. Small world. Well, thanks so
Yep.
much, Mike. Really appreciate it.
you.
Fantastic job. And I'm sure I'll follow up with a question or two here or there as time goes on, and we'll get a copy of the PDF to everyone. Again, if you need ICCCs, everyone will get a copy of the PDF presentation today. There's also a flyer that we're going to send out with it, and then you'll get a course evaluation from Liz. Just fill out your course evaluation. We'll get you your ICCCUs, and don't give her 48, 72 hours to send that out. It's not going to be in the next 17 seconds. So have a little patience, and we'll get that to you. Thanks for joining us, everyone. Thank you so much, Michael, and we will see you next time. Thanks, everybody.
Okay.